దర్శన్ వేదికగా తెలంగాణ రాష్ట్ర ప్రభుత్వ సహకారాలే ఉండగా హాయిగా మన చదువులు షురు. అదే డిజిటల్ గురు, అదే డిజిటల్ గురు.
Children, now we'll learn some more points and then we'll continue with the problems. Next definition is angle between two vectors. Angle between two vectors. So how is this angle between two vectors defined? Suppose we have vector A like this and another vector B like this. So there is no angle. When you look like this, there looks no angle between them. But we have to draw a vector equal to this vector with same initial point like this. With same initial point, you draw the vector B. Then this angle, there are two angles here. One is this angle, another one is this angle. So the angle which is less than 180 degrees, the angle which lies between 0 and 180 degrees is called as the angle between the two vectors A and B. And it is denoted by this symbol AB. So angle between two vectors A and B is denoted by the symbol AB. So it is an ordered pair of vectors A and B. So this symbol denotes the angle between the two vectors A and B. Now we'll write the definition. Suppose that A and B are, let A be vectors. A, B be two non-zero vectors. And then let OA is equal to A and then OB is equal to B. Then the measure of angle AOB which lies between 0 and 180 is called as the angle between the two vectors, is called as the angle between the vectors A and B. Is called as the angle between the vectors A and B. And it is denoted by AB, ordered pair AB like this. Okay. Now we have the properties. Angle between AB is same as angle between BA. Angle between AB is same as the angle between BA. Next property is angle between AB. This is the angle between minus B will be in this opposite direction. Minus A will be in this direction. The angle between AB and is same as angle between minus A and minus B. So angle between AB is same as the angle between minus A and minus B. Suppose that the angle between A and B is 0 degrees or 180 degrees. That means they coincide. A and A will coincide, and then or A is in this direction and B is in the opposite direction. The angle between A and B is 180 degrees. Then we say that A and B are collinear vectors or parallel vectors. Collinear or parallel vectors. So there may be the angle between them. If it is 0, then they coincide. If it is 180, then they will be in the opposite direction. So in any case, they will be collinear. So collinear vectors are parallel vectors here. So we can, when the angle is 0 or 180, they are parallel vectors. Suppose that the angle between A and B is 90 degrees. Then we say that A is perpendicular to B. A vector is perpendicular to B, or A is orthogonal to B. We use this word orthogonal also. A is perpendicular to B. This is all about the angle between two vectors. Angle between two vectors. Next is the division formula, which you have in 2 dimensions also. The similar division formula. Okay. Now suppose that AB is a vector. A position vector is small a bar. B position vector is small b bar. That means OA is equal to A and then OB is equal to B. OA is A and OB is B. Now suppose that C is a point which divides AB in the ratio m is to n. C is the point which divides AB in the ratio m is to n. Then the position vector of C. Position vector of C means OC. OC is given by the formula mb plus na by m plus n. So if it is dividing, C divides. So C divides AB in the ratio. C divides AB in the ratio m is to n. Internally, in the ratio m is to n internally. Then the position vector of C is given like this. Suppose C divides AB externally. Suppose A is like this, B, and C is dividing externally in the ratio m is to n. Then the position vector of C is given by mb minus na by m minus n. So this is by m minus n. So this is the position vector of the point C, which divides. So here C divides AB in the ratio. C divides AB in the ratio m is to n externally. In the ratio m is to n externally. So in that case, the position vector of C is given by this formula. So now what is the midpoint of position vector of the midpoint? Position vector of the midpoint of AB is A plus B by 2, because in this case the ratio is midpoint, it is dividing internally. So the ratio becomes 1 is to 1, 1 is to 1, m is 1, n is also 1. So the position vector of the midpoint becomes A plus B by 2. Next we have 3 definitions which are very, very important. The 3 definitions are very, very important. Only definitions. The definition, first one is linear combination of vectors. Linear combination of vectors. So what is this linear combination of vectors? Now suppose that you have n vectors, let a1, a2, so on, an are n vectors, and then same number of scalars we take. We'll take the scalars as L1, L2, so on, Ln are scalars. These are n vectors and scalars. Then the vector are given by L1, A1, multiply each of them by these scalars, L1, A1 plus L2, A2 plus so on, Ln, An. This vector is called as the linear combination. Is called as the linear combination of the vectors. Linear combination of the vectors a1, a2, so on, an. So the linear combination of the vectors a1 to an is given by this vector. This vector is called as the linear combination of the vectors a1, a2, so on, an. So the next definition is linearly independent vectors. Linearly independent vectors. So what are these linearly independent vectors? Now here also you take n scalars and vectors. So let a1, a2, so on an be n vectors, and then l1, l2, so on ln be n scalars. Be n scalars such that, suppose that there are n scalars such that L1 A1 plus L2 A2 plus so on plus Ln An is equal to 0. Suppose that the sum of all these vectors is equal, sum of all the linear combinations is equal to 0. Then if all the scalars, L1 is equal to 0, L2 is equal to 0, so on Ln is equal to 0. All the scalars are equal to 0. And if all the scalars L1 are such that, all the scalars are such that each of them is 0, then these vectors A1, A2, so on An are called as linearly independent vectors. They are called as linearly independent vectors. So if you have a relation like this, L1, A1, so on is equal to 0, and if all the scalars are such that each of them is equal to 0, then the vectors are called as linearly independent vectors. Now next is linearly dependent vectors. Linearly dependent vectors. Linearly dependent vectors. Now suppose that a1, a2, so on, all these are in vectors, and then l1, l2, so on ln are scalars. Suppose that L1 A1 plus L2 A2 plus so on Ln An is equal to 0, implies that at least one of the scalars implies that at least one of the scalars L1, L2, so on Ln is not 0. So few of them can be zeros, but at least one of them should not be 0. At least one of the scalars is not 0, then these vectors are called as, then the vectors a1, a2, so on an are linearly dependent vectors. So linear combination of vectors, next linearly independent vectors, next linearly dependent vectors. So in the linear combination, you will have this expression which is R, that is the linear combination of the vectors. Now in linearly independent vectors, you will have this equation 0, which implies that all the scalars, if all the scalars are equal to 0, then the vectors are called as linearly independent vectors. Now if at least one of the scalars is not 0, then it is called as, then the vectors are called as linearly vectors. First problem I'll write here. If the vectors minus 3i plus 4j plus lambda k and mu I plus 8j plus 6k are collinear. This is very important problem. Are collinear vectors. Linear vectors. Then find lambda and mu. So these vectors, we'll take them as, suppose that A is equal to minus 3i plus 4j plus lambda k, and then B is equal to mu I 6k. Now we know that A and B are collinear. A collinear. So which implies that their corresponding coefficients are proportional. So that means we have minus 3 by mu I coefficients ratio is equal to k coefficients ratio lambda by 6. They are proportional. So we'll take the first one. So minus 3 by mu is equal to 4 by 8, and then implies that mu is equal to minus 6. So this is mu value. Next again is equal to 6. So by so lambda is equal to 3. So like, so when two vectors are collinear, we know that coefficients are proportional. So we do like this. Show that the points. Show that the points. Show that the points whose position vectors are minus 2a plus 3b plus 5c, a plus 2b plus 3c, and then 7a minus c are collinear. So that they are collinear when A, B, C are non-coplanar vectors. A, B, C are non-coplanar vectors. They are non-coplanar vectors. Now you must show that these are the points. So you will take them as A. Let OA is equal to minus 2a plus 3b plus 5c, and then OB. This is B point. So B is a plus 2b plus 3c, and then OC is C point, that is 7a minus c. Now convert them to vectors, two vectors. Convert these two into two vectors. So what is AB vector? OB minus OA. OB minus OA. Now subtract OB minus OA. When you subtract, you will get 3A minus B minus 2C. Now find AC vector. AC or BC. Convert these 3 points into two vectors. AB, B vector, BC vector, or AB vector, AC vector, any like that. So AC is OC minus OA. Subtract this minus this means 9A minus 3B minus 6C. Now you can see, you can write this as, when you take 3 commonities, 3 into 3A minus B minus 2C, where you can write it as 3 times AB. So you are writing one vector, AB vector, as some scalar times AC is equal to 3 times AB. So that means AC and AB are collinear, implies AC and AB vectors are collinear. When the vectors AB and AC are collinear, the points, because A is common in them. A is common. So the points A, B, C are collinear because A is common. A is common in AB and AC. So you can have AB and AC in the same line. AB and AC in the same line like this. So the 3 points A, B, C are collinear. So like this we prove. Okay, next problem. Next third problem. Let A, B be non-collinear vectors. If alpha is equal to x plus 4y into A plus 2x plus y plus 1 into B and beta is equal to y minus 2x plus 2, y minus 2x plus 2 into A plus 2x minus 3y minus 1 into B are such that 3 alpha is equal to 2 beta. Then find x and y. Then find x and y. This is the problem. This is again very important problem, and it is direct problem. You will just find 3 alpha and then 2 beta, equate them. So in the solution you are given alpha and beta. Alpha you write is equal to, and then beta also you write, and then you are given 3 alpha is equal to 2. So multiply this whole thing is 3x plus 4 is 12y into A plus multiply all these also with 6x plus 3y plus 3 into B is equal to 2 beta. Multiply all this with 2. Then it becomes 2y minus 4x plus 4 into A, 2y minus 4x plus 4. Next plus multiply here also with 2, then it becomes 4x minus 6y minus 2 into B. Now equate the coefficients of A and B. Because A and B are non-collinear, A and B are non-collinear, they are independent. So we can write equating the coefficients 3x plus 12y. A coefficient is this, and here A coefficient is 2y minus 4x plus 4. And then when you equate B coefficients, it is 6x plus 3y plus 3 is equal to 4x minus 6y minus 2. Now just to simplify, write all the terms on one side, then it becomes 7x minus plus 10y minus 4 is equal to 4. And then here 2x plus 9y is equal to minus 5. Now just to solve them. Solve these two and find x and y. You multiply this with 2 and then this with multiply this with 2 and then this with 7 and add. Now we'll solve these two equations. So minus and then plus. So these two get cancelled. So this is minus 43y is equal to plus 43. So implies y is equal to 43 by minus 43, that is minus 1. Now we'll substitute. Substituting in equation, any equation will We'll substituting in equation 1. What is that equation 1? 7x. So 7x plus 10 into y. Y is minus 1 is equal to 4. So 7x minus 10 is equal to 4. 7x is equal to 14. So x is equal to 14 by 7, that is 2. So therefore x is equal to 2 and then y is equal to minus 1. So this is your answer. Now take down the homework. So homework, first problem, a is equal to 2i plus 5j, 2i plus k, and then b is equal to 4i plus mj plus nk are collinear vectors. Find m and n. This is first. Second one I'll write here. B with position vectors a plus 2b, 2a minus b, a, 3a plus b respectively. Now express the vectors AC, DA, BA and BC in terms of A and B. So what is AC? AC is OC minus OA. This is OA, OB, OC, OD. So AC is OC minus OA, like that. You subtract, simplify. So you'll get the answers as minus 2B and then minus 2A plus B and then 3B minus A and then B minus A. This is the answer. Now we'll take two more problems for homework. Okay, next. A, B, C are non-coplanar vectors. A, B, C are non-coplanar vectors. Then test the collinearity. Of the following points. Collinearity of the following points. Whose position vectors are. So you must find out whether they are collinear or not. So first bit, A minus 2B plus 3C and then 2A plus 3B minus 4C and then minus 7B plus 10C. So here you will get the answer as collinear. They will be collinear. So what is the procedure? So first you will find out this is OA, OB, OC. Then you convert them to two vectors AB and AC. Then you see AB is equal to lambda times AC, or else the coefficients will be proportional. Any method you can use. So next 3A minus 4B plus 3C and then minus 4A plus 5B minus 6C, then 4A minus 7B plus 6C. So here you will get not collinear. So the answer is not collinear. So that means they are not proportional. When you solve the problem, you will not get A1 by B1 is not equal to A2 by B2 like that. So we can complete this in next.
చదువులమ్మ నేరుగా ప్రతి ఇంటి గడప చేరగా మీ భవితకే భరోసా దూరదర్శన్ వేదికగా తెలంగాణ రాష్ట్ర ప్రభుత్వ సహకారాలే ఉండగా హాయిగా మన చదువులు అదే డిజిటల్ అదే